Non-homogeneous linear differential equations with constant coefficients. At the end of this lesson, you should be able to solve the second and higher order non-homogeneous linear differential equations with constant coefficients using the method of undetermined coefficients. Basic concepts. Consider the nth order non-homogeneous linear differential equation and its associated homogeneous equation. Any function yp free of arbitrary parameters that satisfies the non-homogeneous equation is said to be a particular solution or particular integral of the equation, and the solution for the associated homogeneous equation yc is called a complementary function. Therefore, the general solution for the non-homogeneous linear differential equations with constant coefficients is given by the summation of yc and yp. There are two common methods for finding the particular solution yp. We can use either the method of undetermined coefficients or the method of variation of parameters. In this video, we will go through the first method, which is the method of undetermined coefficients. Method of undetermined coefficients. The underlying ideas in this method is a conjecture or educated guess about the form of yp that is motivated by the kinds of functions that comprise the input function g of x. We consider 6 cases as given in this table. Note that the method of undetermined coefficients is not applicable when the input function involves ln x, 1 over x, tangent x, or sine inverse x. If any yp contains terms that duplicate terms in yc, then that yp must be multiplied by x to the power of n, where n is the smallest positive integer that eliminates that duplication and to make all terms in yc plus yp linearly independent functions. Example, construct the general form of yp for the differential equation y double prime plus 3y prime plus 2y equals to g of x for each of the following input functions. Do not solve for the constants. Solution. First, we need to solve the associated homogeneous differential equation y double prime plus 3y prime plus 2y equals to 0. Its auxiliary equation is m squared plus 3m plus 2 equals to 0. And the roots for the auxiliary equations are m equals to -2 or m equals to -1. Therefore, the complementary function yc is equals to c1 e to the power of -2x plus c2 e to the power of -x. Next, we need to determine the general form of yp for each of the given input function. For question A, the trial form of a particular solution is assumed to be yp equals to ae to the power of 4x. There is no duplication between yc and yp. Thus, the final form of particular solution is yp equals to ae to the power of 4x. For question B, the trial form of a particular solution is assumed to be yp equals to ax squared plus bx plus c. Since there is no duplication between yc and yp, then the final form of particular solution is yp equals to ax squared plus bx plus c. For question C, the trial form of the particular solution yp is assumed to be the sum of the trial particular solution for each term in the input function g of x. Since there is no duplication between yc and yp, the final form of yp is given by ae to the power of negative 3x plus b cos 5x plus c sin 5x. Watch the next videos for more examples.